All right. See, started with okay again. I can't help it. It's something better. Today, the weather is supposed to be 26 degrees outside. That's what I'm going to start with, the weather. It's going to be a balmy 26. Tomorrow, I believe, it's supposed to be 28. And the next day as well. It's like summer has not left us yet, because it is still summer. I have been my whole life, I thought once we hit school, it was fall. But that's a lie. It's like September 27th or something is the beginning of fall. Right? Exactly. My children have came home and told me these things. I learned from grade 2. You know, I was going to say grade 2-year-olds, but that does not make sense. Yeah. All right. So, we'll do Fun Fact Friday maybe, on Fridays. Let's see. Okay. The factor theorem is very similar to the remainder theorem, except that the remainder is 0, which we know, because if something is a factor, that means it's an x-intercept, which means its y value is 0. And when we use the remainder theorem, we're literally just using function notation, right? P of an x value equals a y value. And when that x value corresponds with a y value of 0, it's an x-intercept, right? A polynomial p of x has an x minus b as a factor if and only if p of b, bless you, equals 0. If p of b equals 0, it's an x-intercept. Therefore, x minus b is a factor. We've stated this a whole bunch of times, right? So verify that x plus 2 is a factor. The only way you know how to verify it right now is remainder theorem. That's it. That's all you got in your toolbox because I've not taught you anything else. Today is the day to learn more, but you have not learned that yet, okay? So if I ask you to verify it, you can't just take a picture of your calculator and post it on your diploma. So that's not going to work, okay? So the only way you're going to be able to verify it is algebraically with remainder theorem, right? So let's try it out. So we have f of x. I need to reset this to a thin marker the whole time. Anyways, phi starts with the letter f, fun fact. And so I wanted the f. F of, I don't know where I was going, f of negative 2 equals 0 would be how we would verify it, right? So verify is another fancy word for when you were in elementary school and your teacher said to check it. To check it, you went and you filled it in for left side, right side, saw if they matched, right? Math terminology is actually verify. So we're going to plug in for our function notation, which we were taught in grade 10. Negative 2 cubed plus 5 times negative 2 squared plus 2 times negative 2 minus 8 equals 0. Please just don't go 0 equals 0 at this point because you're like, verified it. I don't have to type it in. Show some work in between because what they always state is if I can't just go from that to 0 in my head, you can't do that. Okay? So they'll take off marks on your diploma, and we don't want that to happen. So at least do one more step. So negative 8, 5 times 4 is 20, minus 4, minus 8 equals 0. And now I could go negative 8 is negative 16, minus 4 is negative 20, and then plus 20 is 0. So as a teacher, I can say, hey, they can do that, right? Now, the biggest thing about verifying is you have to put, yes, left side equals right side, and enjoy the LS equals RS. It is the only short form you're allowed to use because LS in math terminology actually stands for left side. It's a great thing. It's the only short form you're allowed. So let's see. So we're going to go LS equals RS. Okay? So the next one, for example, is x minus 2 a factor? Try it out. Is x minus 2 a factor? We're going to do remainder theorem, and then you're going to type that in and see if when you put in a 2, you get a what for your y? 0. So you're going to check with your calculator too. We're going to do both. So go. Try it out. I believe in you. So remember, for this one, you're going to type this into your y equals, right? And you can either go second graph, go to your table of values and look for the value of 2, right? And see if you get a 0 for your y. Or remember, you could go second trace. You forget about this, second trace, which is calculate value, number 1. Second trace value. And then it pops up x equals, and you can put in a 2. Now, the second trace value is much more helpful when your actual number is not a whole number or an integer, right? When it's a decimal, because your table of values doesn't pop up whole numbers and integers. Most of you guys have it set Sorry, to pop up whole numbers and integers, not to pop up decimals, right? So let's try it out. Using remainder theorem, I'm gonna say let p of x, because I like p, but you can pick whatever you want, equal x cubed minus 6x squared plus 3x plus 10. And then I can go p of 2 equals 2 cubed minus 6 times 2 squared plus 3 times 2 plus 10. P of 2 equals 8 minus 24 plus 6 plus 10. 6 and 10 is 16 plus 8 is 24. Minus 24 is 0. So you'd say x minus 2 is a factor because when using the remainder theorem, the remainder is 0. Right? And if I get a different value other than 0, it would not be a factor. And the reason why it wouldn't be a factor is it wouldn't be an x-intercept because my y value would be something else. Would it be a coordinate on the graph? Yes. But not an x-intercept, therefore not a factor when I work the graph. Yep? Yes. Oh, we're starting. If you can hold it, I would wait. Up to you because this is all brand new. But, or rush. Go at fast pace. All options to you. I believe you can go quickly. Yes. Believe. Okay. So we're learning how to factor something larger than a squared, larger than a quadratic. Quadratics come up a lot in here because we're going to need to be able to factor a quadratic anyways. But right now it just says factor. So at last, we're going to consider how we can write a polynomial that is being given to us in expanded form, in factored form. We do this by combining the knowledge we have previously acquired. So this asks us to factor x cubed plus 2x squared minus 5x minus 6, which means I'm going to need a factor in order to factor it, right? How can we tell if something is a factor? When we plug it in, we get a remainder of 0. We agree? So I'm just going to randomly plug in integers from 1 to bajillion and hope that I get a 0. Is that productive? Is that the fastest way to go about it? No. A few of you are going to your calculators. That actually is the fastest way. But there's also a question that comes up every so often that says, what are the possible integral numbers that could be factors? What are the possible factors? So when it says possible, and before calculators came about, which those little graphing calculators came out when I was in grade 10, it was the first year, so I actually know how to use them. It would have sucked. It was the year after. But those lovely things came out in grade 10. Previous, so I had to learn, I got to use my calculator. But previous to that, there was no calculator. So you couldn't go look for a what? What are we going to look for in our calculator? An x-intercept, right? And then work it back, we have our factor, right? We know that. Previous to calculators, though, and if they took it out of your little grippy hands, what would you do? Well, we wouldn't want to just use all the numbers positive and negative from 1 to a billion and hope we hit 1, right? Not productive. But possible factors always come from the constant. Remember, it's a constant. Constant is the number without a variable, because if I filled in the number 2, x cubed would change, 2x squared would change, negative 5x would change if I filled in the number 2, right? This would become negative 10. But negative 6 would never change because it's a constant. It doesn't have a variable, correct? If I plugged in negative 1 cubed, that would change. 2 times negative 1 squared, that would change. 5 would change. But negative 6 would never change. It remains constant because it doesn't have a variable. So we always look to the constant, and we state the integers of its factors. So the factors of 6. What can I multiply to get me 6? That's the factors of it. Yeah, Seamus? 2 times 3, Colin?
1 times 6.
1 times 6. So we have 4 of them, right? We have 1, 2, 3, 6. Now what we need to do is we need to go plus or minus, because we actually have 8 that we can choose from, plus 2. Yeah. I believe in your question. What was your question? No? She does not believe in her question, but I believe in it. Okay. So, before a calculator result, we'd actually have to literally guess and check. So we would plug in positive 1. See if we get, what? 0. Plug in negative 1. See if we get 0. And we plug them in until we got one that got us a 0. Okay? So, not the fastest way, but it is a way. So sometimes they ask for the possible factors. And the key word here is possible. So say I had x minus 2. That's a possible factor of this, right? If I plug it in, I might not actually get a remainder of 0. I didn't ask for what are the factors. I said what are the possible factors. And so it would be 1. So they sometimes ask that tricky little question. A little ditty like that. Okay, so possible factors could be x plus 1, x minus 1, x plus 2, x minus 2, x plus 3, x minus 3, x plus 6, x minus 6. Those are possible. Doesn't mean that if you plug them in, you get a 0. Difference in asking the question of what is a factor, what's a possible factor. Okay? So we could practice by plugging them in, but we're going to go to our calculator. So we're going to plug this into our y equals x cubed plus 2x squared minus 5x minus 6. I always pick they might all show up on your table of values, all the x-intercepts, if they're all whole numbers. One might show up. For the purpose of trying to be consistent, because we could all pick a different one and solve this out, right? If all 3 factors were on there, or all 3 x-intercepts, you could pick 3 different ones and we'd all be solving it differently. But we'd end up with all the same factors in the end, right? We still would, but we'd solve it differently. So what I always do so that we're all solving it the same, because it makes it just a little bit easier, is I always pick the smallest x-intercept, like the lowest one. So what's the lowest x-intercept in your table of values? Negative.
3.
Negative 3. You can arrow up and down to see more of your chart, just so you know, because I didn't realize people don't know that. So like last year, and then people were like, I can't see more, and I'm like, up and down. Okay? So negative 3 is the lowest?
Yes.
There's also what on there? Negative 1, I think?
Yeah.
And then there's another one?
2.
2. So we actually have all 3 of them. So we know what we're going to be looking for here. It's actually given to us. We know that they were x equals negative 3, negative 1, and 2, you said? So we know that's what we're going to be heading to. Are those factors, though? No, those are what? X-intercepts. It's another word for x-intercept. Roots. And zeros. Yes, we got them all. So those are actually the x-intercepts. So if I said factor and you gave me those 3 answers, would you be right? First off, no, because you gave me the roots. Second off, no, because you gave me no work. Honestly, a correct answer with no work on the diploma is 0. They don't give you 0.5. That would stink, wouldn't it? We don't want to be those people. So we should factor this showing all your work. So, are you following me? You with me? This seems a lot harder than it is. I'm forewarning you because it's actually ridiculously easy, but your little brains overwhelm yourselves. And you're like, I mean your large brains, super large, ginormous brains overwhelm yourselves. Okay? This is the easiest lesson of the year. I'm not even joking. I'm not like, haha, and then throw crap at you. Like, it's seriously the easiest lesson. Okay? With me? All right. So I'm going to use the smallest one. I always use the x-intercept. If for some reason you fill it in and you don't get a remainder of 0, 99.9% of the time you put in your y-intercept, you silly, silly person. You pick the one where the x was 0, not the y was 0. It's easy to do off of the table of values, a little oopsie, right? We need x-intercepts, not y. So I'm going to use the negative 3. So this is what we do. Following on? I always go x equals negative 3. And I remember very little of my childhood because all of math has taken those memories and thrown them out because I maxed out about 10 years ago. And so all my childhood memories are falling out and math is just going in. So, of my childhood memories, I remember 2 for specifically things. 1, I remember doing this. And it's called synthetic division. My brain stopped. It halted. See? Lost memories. So I remember doing this, and my teacher said, make an L. So I made an L. And the L was not large enough. And then I had to erase it. Oh, so rude. And if I wrote in pen, I had to use that whiteout that didn't dry for like 27 years. You guys have those like, zig, zig, you're fine. No, I had to use the one, by grade 11 or 12, I got the one with the foam end, At least it made it smooth. Before that, it was the bristle end. Well, you might as well have wrote your notes while riding on a bus in Saskatchewan because it was just bumpy. But it also took 27 years, so it was bumpy and wet. So, I'm helping you out here. You need 2 lines. When you draw the L, 2 lines. If you don't draw 2 lines, that's on you. Okay? You need a space of 2 lines. Like 1 row of numbers, 1 row of numbers. 2 lines. If you make your L too short, that's your problem. You're erasing because you did it. I forewarned you. You're welcome. Okay? Everyone has gotten to this point. There's going to be someone erasing. That's what's going to friggin' happen. Someone will have listened. Okay. Step 2. Well, that's kind of 1 and 2, but I don't feel like the L is a step, but we'll pretend it is. So we're on step 3. We have to make sure we can count down our exponents. Like, if you cannot count down like a rocket, bad. Okay? So, 3, 2, 1. What would this one have? It would actually have x to the 0, because x to the 0 is just a 1. 3, 2, 1, 0, blast off. If you can do that, life is good. If you can't do that, you have to put a 0 in for the placeholder. Okay? So if it's like 3, 1, 0, because there's no 2, there's no exponent, there's no x squared, you have to put a 0 in its place. So you have to be able to count down like a rocket. If you can't, a 0 has to go in so you can count down like a rocket. You have to be able to blast off. Okay? So, all we do up here is we put the coefficients. This one has a 1, so we're going to put a 1, then a 2, then a -5, then a -6. We good? This is not rocket science. It is a little bit because you have to count down like a rocket. So we're going back to kindergarten. They did the blast off thing in kindergarten. We just full circle it right there. So 3, 2, 1, 0, blast off. If we say this one was missing, say the 2x squared was missing, we would put the coefficients of 1, 0, 5, -6. You need the placeholder. Okay? Does that make sense? Everyone follow me? This is not a hard concept, but if I take away one of those, so many people will call me over and be like, it doesn't work. The x-intercept should work. It doesn't. It's because you forgot a placeholder every single time. Not like 7%, like 100% of the time. You forgot to check for it missing one. Okay? All right. From here on, we are going to put an arrow, and then we are going to multiply, add, multiply, add, multiply, add, multiply, add, until we can't multiply and add anymore. That's what we are going to do. It's going to be a great time. Okay? Look at this. Arrow. Do you see there's 2 spaces for 2 lines? If you didn't do that, you're going to be erasing. You're going to be that person. Don't admit it, because that'll show that you weren't paying attention. Okay. Drop down the number. Everyone following me? Now we are going to multiply, add, multiply, add, multiply, add, multiply, add, and then stop. Okay? What 2 numbers do we have here? Oh, look. And we multiply. -3 times 1 is? -3. I'm going to draw arrows for now, but I will never do this again. -3. And then we multiplied, so now we're going to add. 2 plus -3 is?
-1.
-1. We added, so now we're going to multiply. -3 and -1 is? 3. We multiplied, so now we're going to add. -5 plus 3 is? -2. We added, so now we're going to multiply. -3 and -2 is? 6, and our happiness should be happening here, because what is this? 0. We box it. It's our remainder. We should be so happy, because if our remainder is 0, we didn't pick the y-intercept. Or we didn't add integers wrong. -3 plus 1, -4 happens all the time. Okay? Your integer math goes down here. So, at least when you get to 0, you know you did good, right? You done well. Okay? Now, what is this x equals -3? What is this in this graph, pertaining to this graph? What is this? X-intercept, because my y is? 0. So instead of doing remainder theorem, I could actually do synthetic division. That's what this baby's called. And I'd be like, got a remainder of 0. Okay? You could do it that way too. Often it's more work, so most people don't choose it. However, you can. Now this is the catch. This is my x-intercept. We agree? So what's the factor? X plus 3. You guys forget about this one. This one gets forgot about all the time. It's just all sad because it doesn't get remembered. Because at the end, I'm going to have to go x plus 3 and then some more factors. Right? It's an x cubed. So an x squared had at most how many factors? A quadratic. How many factors did you ever get out of it at most? 2. And sometimes you had GCF sitting in front, like a 3 and then x plus 2, x minus 4. But you still only had 2 factors. Do you agree? X cubed, how many at maximum do you think it can have?
3.
3. So the largest the exponent is the maximum number of factors you can have, right? I like the number 4 better than 3 anyways, so let's just pretend. Okay, so 3. It can have less if you can't actually factor the quadratic, but at maximum it can have 3. Okay? How do we get the rest? So, if we took an x out, which is what we did, we took an x plus 3 out, correct? What should we be left with? Instead of an x cubed, we should be left with a x squared. It's always one less. So what did we do? We wrote the coefficients without variables, correct? So this is just coefficients without variables. So all this is, if this is x cubed, this then, should be a different color. This then is just 1x squared minus 1x minus 2. I can put the variables back in. So I go 1x squared minus 1x minus 2. And it's x squared because I took an x out, right? It's not x cubed anymore. It's x squared. Do you see that you're going to forget about this bad boy? You're not going to list it at the end? Oh, it's like all the work is done beautifully, and then people forget to draw that, write that factor at the bottom, and they lose marks. It's so sad. Such a sad day. So remember, I always immediately, once I get it, I just write it at the end. I just put it there. Because then I'm like, I can't forget about it because I already did it. Because I do. I forget to write it. Now we need to factor this. Now, you will learn to be super pumped when the polynomial starts with a 1. It doesn't matter if it's x cubed, x4, x5, you will be pumped. Because you're going to have to product sum at the end. If your polynomial starts with a 2, 3, -1, -4, whatever it may be, you're dropping that number down, aren't you? So you're going to have to decomp. So whenever your big polynomial starts with a 1, product sum, go right to brackets. When your polynomial starts with a number, you're going to have to do decomp. So you'll learn to be excited. Oh, 1x cubed. Yes. I'm going to get to do product sum. So let's ask ourselves, what times what equals the first times the last, if you're forgetting your factor? -2. And then what plus what always equals your middle, which is -1. And I do blanks because then I don't mess myself up. So what times what gets you -2? What plus what gets you the middle? -1. What two numbers? I think I heard -2 and +1. Okay. I'm pretty sure that was all that was said. Okay, I can go directly to brackets if there's a 1 in front, correct? I don't have to do decomposition. So I can go x, which is my variable, -2, and x plus 1. And guess what? I already knew where I was going, so let's see if I was right. I have x equals -3, x plus 3. X equals -1, x plus 1. X equals 2, x minus... Oh, jeez, I'm just a genius. Look at that. It's all right. I can walk away happy. Scary high. Bless you. Scary high five. Yeah.
Could you explain the thing with the placeholders again? It just went right through here.
If it went through one ear, it should have stopped. So did it go right through both? Okay, good. I just want to make sure, because I was like, there's like something in there stopping things. So if it went in one, it just got to come back out. Okay. Glad. I'm glad there's something slowing it down in the middle. So that's good. So all I said is, we always took the leading coefficients here and we put them down, correct? So if this is an x cubed and I take one out, this is going to be x squared, x in number, correct? Like you're always going to be one less when you state these variables. So if I'm missing, say, the 2x squared here, so say I just have x cubed minus 5x minus 6. And I list those down. I'm only going to have 3 numbers up here. I won't have enough numbers here to make it be x squared. So I have to say 3, 1, 0. And then I'm like, what? That's the worst rocket ever. That thing ain't starting. That's a crappy rocket. So I would actually have to go x cubed plus 0x squared minus 5x1 minus 6x0. And now I have 3, 2, 1, 0. Blast off the rocket and go. So now I would have 1, 0, negative 5, negative 6. So that's where I need the placeholder. Does that make sense? That went in one ear. Stayed. Okay, make sense? I don't know why you're taking pictures of him. Second off, I don't know why you have the brightest flash on known to man. I literally lost an eyeball. And I have had glasses since grade 4. This eye does not need problems. Okay? We're going to call you Schmookus because we can't see your real name. All right. We're in try number 2. What are the possible factors? There's 1. 1 is always one of them, just so you know. So that is good. 1 and 15. 3 and 5. And 3 and 5. Now, no. You can put it however you want. I always go lowest to biggest just because then it makes my heart sing. That's it. It just brings me joy. Okay? On the diploma or on a unit test, I would always show that the number you found off of your calculator actually gets you a remainder of 0, which you'll indirectly do with your synthetic division anyways, right? So you're proving that. So some people will say, do I have to show the remainder theorem to show that it works first in order to do the synthetic division? No, because your synthetic division shows that the remainder is 0. You're just double dipping here, right? So if you want, you can say the remainder is 0. You can write that beside it, remainder 0, and that can help you out. But if you show remainder theorem and synthetic division, it's showing the same thing, right? Okay, so go to your calculator. Typing it into your y equals.
My graph just says invalid.
Invalid dim? Oh. That's one you're never coming back from. Never. Never coming back from this. Might as well burn that calculator. Just burn it. Yeah.
Go outside.
Bonfire. On that non-grassy knoll thing. The pretend grass hill. That we'll have grass fed. He's really spending time on this. You could just reset it.
Oh, okay. I'll try.
Yeah. If not, if you don't want to reset it, burn it. I'm sure that will help. The dim mismatch sometimes often dim mismatch means you have stuff in your lists that are opposite. Did you fix it?
No.
So often you have stuff in your list which you don't even know about. So it means someone probably touched your calculator. So I would just reset it. It fixed dim mismatch immediately, or burn it. No, reset it. Grant. Second.
Okay.
Plus sign. You were going to press the button at the back. Girl, please. Okay, second plus sign. Number 7. Over to reset all. Yep. And then yes. The button doesn't do it. The button only goes so much. Oh my gosh, you're done. There is a button in the battery. Grant in the battery. But just so you know, that is not the way to go about it.
Yeah, you're sure there's a technique? You don't think it older one, they don't have to.
Yeah.
Mine's the
It just depends on the calculator. See, Grant, if you look here, you see this like Some of them do have it, some of them don't. See, mine is a little bit, so I can use like what x-intercepts appeared? X equals -5. Anything else? Pardon?
-3. -3.
Anything else?
-1.
-1. Now, often you will get all three when you have a 1 in front, because you're going to get nice factors like x plus 2, x plus 1. When you do decomp, let's think about this. When we do decomp, we often get like 2x plus 1 and x minus 4 or something like that, right? And this one will be nice, x equals 4. You'll find it on your table. This one will be x equals -1/2, and most of you only have integers on your table, so that's not going to show up, right? So when you're doing plain old product sum, when there's a 1 in front, you often will see all three of them on your table of values. When you have like a 2 or something in front, often you won't, because you have to do decomp, and one of them, at least one, will have a fraction, sometimes 2. Okay, back to this question. So I'm going to start off with the smallest one, or the lowest one. So I'm going to do x equals -5. And before I even do this, I'm going to be like, boom, x plus 5. Before I even go on with my L, I'm going to go, x plus 5. Don't forget it. Yes, you're here. We can move on. Okay? Then we make an L that can contain 2 lines worth of knowledge. And then we go back to kindergarten and we rocket ship. We say, 3, 2, 1, 0, blast. Yes. I can put my numbers in. So glad this recording doesn't include like video. Yes. Okay. 1, 9, 23, 15. What do we do first? Bring down the 1. Some people get stuck here. And if I'm just like, bring down the 1, they're like, and they could do the whole thing. So bring down the 1. Then what do? We multiply. -5 times 1 is -5. Then we add. We subadd. Yes. 9 plus -5 is 4. And then we multiply. -5 and 4 is -20. And then we multiply, so now we add. 23 minus 20 is 3. And then we multiply. And then we add and we get, and then we're happy. If we don't get a 0 in that box, you messed up. Things are bad. Okay? Then we get 1x squared plus 4x plus 3. And then we factor it. What times what equals 3? What plus what equals 4? 3 and 1. We get x plus 3, x plus 1. So I'm just going to give you cubic homework. Yay. Tomorrow we do 4 and 5, and then we do solving. So when you have x to the 4 and x to the 5, what's going to happen is you are actually going to have to do synthetic division more. Until you knock it down. I know. It's exciting. You're welcome. It's a gift. So your homework is going to be number 4 literally just asks what the possible zeros are. So if you do synthetic division, stop yourself. It's just the possibles. It's what we did in that very first step. And then number 5, please remember to ask, can I count down? So for example, for B, x cubed, I'd be 3, 1, 0. That doesn't work. So I'd be like, oh, dude, missing the 2. So I go 1, 0, -27, and 10. So always check for if you can count down.